These are the stat corrections on test 3. First question is, what is the explanatory variable in this setting? That would be the car weight. It's on the x-axis. Next question, does the scatter plot show a positive, negative association, or neither? And that is negative. We would expect the association to be negative, so that means the R value should be negative. The closest one is negative 0.6. Negative 0.9, the dots would be almost perfectly linear. Because the unusual point is in the y direction, removing it would not cause much of an effect. This point has a lot of other x values around it. So the residual is big, but because there's a lot of x values around it, the correlation would not change that much. If the car weights were converted to metric tons, the correlation would not change at all. The units have no effect on correlation. Okay, in this particular problem, they're asking us to interpret the slope. The slope is 21.83. What does that mean? For each additional 1,000 students enrolled, we would expect the number of property crimes to increase by 21.83 on average. The next question is asking us to predict. To predict, we need the prediction equation, which can be calculated by using the least squared regression line right there. So we predict about 193.04 crimes. Now we're asking to find the residual. So in order to calculate the residual, we need to use this equation, R equals O minus P. O stands for the observed number of crimes. So if X is 14, what did we observe? Well, we observed 138 crimes. So that goes in for O. P is what we just found. We predicted 193.04 crimes, so there's a difference of negative 55 crimes. That's your residual. Next, they're asking for a residual plot. Most students did not provide a scale, either on the x-axis or the y-axis. You have to provide a scale, and your scale should be somewhere from like 2 to about 26. So you can go maybe in increments of 5. And then your residuals have to have a scale also. And to get those numbers, you should be looking at the window on your calculator. I'm getting too many residual plots with no scales on them. Would the slope of the regression line change if we removed this point? This point is an influential observation. I would expect the slope of the line to decrease, maybe become even more horizontal. So I would expect the slope to get closer to a value of 0. The slope should decrease. Last question, is the least squared regression line a good model for the data? I believe so. I believe because the residual plot reveals no pattern and the correlation is strong, which is the R value, I believe a linear model is appropriate. You have to refer to the residual plot to answer this question. Tell me if you believe that the residual plot has a pattern in it or not. If it has a pattern, then you would not believe a linear model is appropriate. But if the residual plot is random, then that would provide evidence that a linear model is appropriate. Students had a lot of trouble with this question, interpreting R squared. Basically, you have to say 80% of the variation in crimes can be explained by the LSRL of crimes on enrollment. You have to memorize that sentence. You have to know how to write this. Last page of the test, the first question is asking for an equation. So I need those two numbers to write the equation. So my equation is the predicted number of floors climbed. I use this hat symbol to show my teacher that this is a predicted amount, and then equals the intercept plus the slope times minutes. You don't forget to define your variables. If you just wrote x here, you didn't tell me what x is. If you wrote just y hat, you have to tell me what y hat is. And finally, you have to interpret what the S value means in context. So basically you want to say the average difference, S is the average difference between the number of observed and predicted number of floors climbed for a fixed value of minutes, which is 2.34. It's the average distance of a residual. It's the average length of a residual. But you can't say residual because you have to tie it into the context of the problem.